All right, so this video is kind of an extension of solving by completing the square. So you'll notice we have quadratic equations, and completing the square can be used when factoring is not an option. Like if you try to factor some of these problems, it won't work out because there's not common factors, or the combination doesn't work out. Now, some of these you'd be able to say, well, Mr. Schwandt, it does factor. Like number 7. If you were actually to take number 7, you could actually factor number 7. But we're not going to, because we're going to practice completing the square. So what we're going to do is, if we're completing the square, on the instructions I said for number 7, all the odd numbers, we're going to just factor it. We don't need to solve. And then for 8, 10, and 12, we're going to solve. So let's go ahead and do a few of these here. So like for number 7, in order to complete the square, I need the perfect number behind 14x. So what we do is we take half of b, so b divided by 2, and then we square it. So half of 14 is 7. 7 squared is 49. Well, negative 15 is definitely not 49. So what we're going to do is we're going to write x squared plus 14x plus something, and then we still have the minus 15 there, okay? And then we still have the equals 0. So what do we want in our blank spot? Well, half of b, which is 7. 7 squared is 49. 49 is what we want in the blank space. But just like a good mathematician, or for those of you who've taken chemistry, we know that if we just randomly add a 49 to the equation, we have to balance the equation out. So if I keep it all on the left side, I can add 49 as well as subtract 49 from this side. Okay? So it's sort of like I balanced it, and you're like, well, wait, if we're just adding 49 and then subtracting 49, what's the point? Okay? The point is I need the first 3 terms right here. So remember in class we talked about perfect square trinomials. Okay? In perfect square trinomials, trinomial 3 terms. And then remember the trick, half of 14 is 7, 7 squared is 49. We've created a perfect square trinomial. Excellent. So what we could do from here is take the square root of x squared, which is x, copy the first operation, plus square root of 49 is 7 squared. And then we just do the math back here. Negative 15 minus 49 actually gives me negative 64 equals 0. Okay, so that would be the factored answer after doing that. And for number 7, 9, 11, that's all you need to do. All you need to do is factor. So let's quickly do number 9. Okay, so remember we want b divided by 2 squared. So b is negative 4. Half of negative 4 is negative 2. Negative 2 squared is positive 4. 91 is definitely not positive 4. So what we're going to do is make our blank space. And then we have the minus 91 equals 7 on the other side. Okay. And again, what do we want in our blank space? Half of b is negative 2. Negative 2 squared is 4. 4 is what we want, but if we add 4, we also have to subtract 4. Okay, and the whole reason we do this is because the first 3 terms give me exactly what I want. A perfect square trinomial. Square root of r is r minus square root of 4 is 2. Okay, and then negative 91 minus 4 is negative 95, and then equals 7. If you wanted to, you could move the 95 over or move the 7 over. I'm just going to add 95 because I like things positive. So that would give me r minus 2 squared equals 102. Okay? So, again, completing the square, the whole reason we have this is because if something doesn't factor, completing the square is something I can do when it doesn't factor out nicely. But we also want to make sure we only want to complete the square if b is an even number, right? Because we did 14 divided by 2 is 7. If you try to divide an odd number by 2, you're going to have a fraction involved, and you could still complete the square, but it makes it a lot more difficult. So these are all perfect opportunities to complete the square, because look at all the b terms are all even. So that is how you just do the factoring part to complete the square. In the next video, I'll teach you how to solve to complete the square.